Hey guys, I think one thing that people don't understand about the ambiguous case is that there are two solutions. And maybe when students hear about the ambiguous case using the law of signs, they think that maybe it's something they don't understand at the very end, that they're supposed to decide which solution works. And the weird part is that there are literally two solutions to this. So let's get into it and see why that is. If I were to give you these instructions to make a triangle, you could make two different triangles. I could do one triangle like this. And this is an acute triangle right now. So angle B is 20 degrees. The side opposite angle B is 10 units. And then side C is 15 units. But I could do an entirely different triangle. And it's an obtuse triangle. And it still has the same exact information that we were given. Angle B is 20 degrees. The side opposite angle B, side B, is 10 units. And then side C is 15 units. So these follow the same instructions that we were given, but they're two entirely different triangles. And this is why the side-side angle case has two triangles. With this case, that means we have to do the law of signs twice. And at the end, there will be two answers. Let's go and look at a problem and see what we need to do. How do we create the second triangle? Well, if you take a look at the first triangle, if you think of this side staying as 10 units, I'm going to try and animate this. So it would kind of swing to the inside like this, and eventually, if it's 10 units, if it stays 10 units, it would land right about here. And because it's still 10 units, that means that these sides are congruent to each other, which means that this triangle here that I just created is an isosceles triangle. And that means that these two angles would be congruent to each other. Now, angle C, we'll call it C1 for a second. If this is angle C1, then this angle here would be considered angle C2. And that's what we created on the other triangle. This here is angle C2. And these are supplements of each other. Angle C1 and angle C2 are supplementary. And to create this other triangle, we're going to take whatever we find C1 to be, and we're going to subtract it from 180 to get angle C2. And you'll see how that plays out in the calculations when we do law of signs on a problem. So let's go and take a look at that. Here we have enough to do the law of signs. We've got angle A, which measures 42 degrees, and then we've got the side opposite, angle A, which is 17. We've got our ratio right there. Sine of 42 divided by 17 equals the sine of C divided by 25. And when we cross multiply, 25 times the sine of 42 equals 17 times the sine of C. I can divide both sides by 17, and that gives me that sine of angle C is 25 times the sine of 42 divided by 17, which means the inverse sine of all of that is angle C. The angle C, 25 times the sine of 42 divided by 17, and then I'll take the inverse sine of that, and we get 79.7. I think we should just call it 80 degrees. Now keep in mind, that is angle C1, we'll call it right now. So that makes this 80 degrees. Based on what I did before, that would make this angle C2 100 degrees. They're supplements of each other. Both situations work just the same. Now that I have angle C, I'm able to calculate angle B in both triangles using just the triangle sum theorem. Angle B on the first triangle is 58 degrees, and angle B on the second triangle is 38 degrees. Now I can do the law of signs for both triangles. the sine of 58 degrees over b equals the sine of, and we can use either one now. We can still use the 42 and the 17, or we can go with the 80 and the 25. It doesn't matter. Sine of 42 divided by 17. And we'll cross multiply just like before. 17 times the sine of 58 equals b times the sine of 42. And we divide both sides by the sine of 42. 17 times the sine of 58 divided by the sine of 42. 21.55 is what I got. 21.55 units for side B. Then, doing the same calculations with the other triangle, sine of 38 degrees over B equals sine of 42 over 17. So 17 times the sine of 38 equals b times the sine of 42. And again, we divide both sides by the sine of 42. And b equals approximately 15.64. Both solutions are viable. It has two answers. So guys, that's what it takes to do a side-side angle case of a triangle. This is the ambiguous case, and I hope it helped.